Aphorisms 41 to 47 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorisms 41 to 47 of Book 2. 41. Among prerogative instances, I will put in the 18th place instances of the road, which I also call travelling instances, and articulate instances. They are those which point out the motions of nature in their gradual progress. This class of instances escapes the observation rather than the sense, for it is strange how careless men are in this matter, for they study nature only by fits and at intervals, and when bodies are finished and completed, not while she is at work upon them. Yet, if anyone were desirous of examining and studying the contrivances and industry of an artificer, he would not be content with beholding merely the rude materials of the art and then the completed works, but would rather wish to be present while the artificer was at his labours and carrying his works on. And a like course should be taken with the investigation of nature. For instances, if we are inquiring into the vegetation of plants, we must begin from the very sowing of the seed, and observe, as we may easily do, by taking out day after day the seeds that have lain in the ground 2 days, 3 days, 4 days, and so on, and carefully examining them, how and when the seed begins to puff and swell and to be, as it were, filled with spirit. Secondly, how it begins to burst the skin and put forth fibres, at the same time raising itself slightly upwards, unless the ground be very stiff. Also, how it puts forth its fibres, some for the root downwards, and some for the stem upwards, and sometimes also creeping sideways, if it there finds the ground more open and yielding, and so with many other things of the kind. In the same way we should examine the hatching of eggs, in which we might easily observe the whole process of vivification and organization, and see what parts proceed from the yolk, and what from the white of the egg, and so forth. A similar course should be taken with animals generated from putrefaction. For to prosecute such inquiries concerning perfect animals by cutting out the fetus from the womb would be too inhuman, except when opportunities are afforded by abortions, the chase, and the like. There should therefore be set a sort of night watch over nature, as showing herself better by night than by day. For these may be regarded as night studies by reason of the smallness of our candle and its continual burning. The same too should be attempted with inanimate substances, as I have done myself in investigating the expansion of liquids by fire. For there is one mode of expansion in water, another in wine, another in vinegar, another in verjuice, and quite another in milk and oil, as was easily to be seen by boiling them over a slow fire, and in a glass vessel in which everything may be clearly distinguished. These matters, however, I touch but briefly, meaning to treat of them more fully and exactly when I come to the discovery of the latent process of things. For it should all along be borne in mind that in this place I am not handling the things themselves, but only giving examples. 42. Among prerogative instances, I will put in the 19th place supplementary or substitutive instances, which I also call instances of refuge. They are those which supply information when the senses entirely fail us, and therefore we fly to them when appropriate instances are not to be had. Now, substitution is made in 2 ways, either by gradual approximation or by analogy. To take an example, there is no medium known by the interposition of which the operation of the magnet in drawing iron is entirely prevented. Gold placed between does not stop it, nor silver, nor stone, nor glass, wood, water, oil, cloth, or fibrous substances, air, flame, etc. But yet by nice tests some medium may possibly be found to deaden its virtue more than any other, comparatively, that is, and in some degree. Thus it may be that the magnet would not attract iron as well through a mass of gold as through an equal space of air, or through ignited silver as well as through cold, and so in other cases, for I have not made the trial myself in these cases. It is enough to propose such experiments by way of example. Again, there is no body we are acquainted with which does not contract heat on being brought near the fire, and yet air contracts heat much more quickly than stone. Such is the substitution which is made by gradual approximation. Substitution by analogy is doubtless useful, but is less certain, and should therefore be applied with some judgment. It is employed when things not directly perceptible are brought within reach of the sense, not by perceptible operations of the imperceptible body itself, but by observation of some cognate body which is perceptible. For example, suppose we are inquiring into the mixture of spirits which are invisible bodies. There seems to be a certain affinity between bodies and the matter that feeds or nourishes them. Now the food of flame seems to be oil and fat substances, of air, water and watery substances. For flame multiplies itself over exhalations of oil, air over the vapour of water. We should therefore look to the mixture of water and oil, which manifests itself to the sense, since the mixture of air and flame escapes the sense. Now oil and water, which are mingled together very imperfectly by composition or agitation, are in herbs and blood and the parts of animals very subtly and finely mingled. It is possible, therefore, that something similar may be the case with the mixture of flame and air in pneumatic bodies, which, though not readily mingling by simple commixture, yet seem to be mingled together in the spirits of plants and animals, especially as all animate spirit feeds on moist substances of both kinds, watery and fat, as its proper food. Again, if the inquiry be not into the more perfect mixtures of pneumatic bodies, but simply into their composition, that is, whether they be readily incorporated together, or whether there be not rather, for example, certain winds and exhalations or other pneumatic bodies which do not mix with common air, but remain suspended and floating therein in globules and drops, and are rather broken and crushed by the air than admitted into or incorporated with it. This is a thing which cannot be made manifest to the senses in common air and other pneumatic bodies, by reason of their subtlety. Yet how far the thing may take place we may conceive, by way of image or representation, from what takes place in such liquids as quicksilver, oil, or water, and likewise from the breaking up of air when it is dispersed in water and rises in little bubbles, and again in the thicker kinds of smoke, and lastly in dust raised and floating in the air, in all of which cases no incorporation takes place. Now the representation I have described is not a bad one for the matter in question, provided that diligent inquiry has been first made whether there can be such a heterogeneity in pneumatic bodies as we find there is in liquids. For if there can, then these images by analogy may not inconveniently be substituted. But with regard to these supplementary instances, although I stated that information was to be derived from them in the absence of instances proper, as a last resource, yet I wish it to be understood that they are also of great use even when proper instances are at hand, for the purpose, I mean, of corroborating the information which the others supply, but I shall treat of them more fully when I come in due course to speak of the supports of induction. 43. Among prerogative instances, I will put in the 20th place dissecting instances, which I also call awakening instances, but for a different reason. I call them awakening because they awaken the understanding, dissecting because they dissect nature, for which reason also I sometimes call them Democritean. They are those which remind the understanding of the wonderful and exquisite subtlety of nature, so as to stir it up and awaken it to our attention and observation and due investigation. Such, for example, as these following: that a little drop of ink spreads to so many letters or lines, that silver gilt stretches to such a length of gilt wire, that a tiny worm, such as we find in the skin, possesses in itself both spirit and a varied organization, that a little saffron tinges a whole hogshead of water, that a little civet or musk scents a much larger volume of air, that a little incense raises such a cloud of smoke, that such exquisite differences of sounds, as articulate words, are carried in every direction through the air, and pierce even, though considerably weakened, through the holes and pores of wood and water, and are moreover echoed back, and that too with such distinctness and velocity, that light and colour pass through the solid substance of glass and water so speedily, and in so wide an extent, and with such copious and exquisite variety of images, and are also refracted and reflected, that the magnet acts through bodies of all sorts, even the most compact, and yet, which is more strange, that in all these, passing as they do through an indifferent medium, such as the air is, the action of one does not much interfere with the action of another. That is to say, that at the same time there are carried through spaces of air so many images of visible objects, so many impressions of articulate sound, so many distinct odours, as of a violet, rose, etc. Moreover, heat and cold and magnetic influences, all, I say, at once without impeding one another, just as if they had their own roads and passages set apart, and none ever struck or ran against other. To these dissecting instances it is useful, however, to subjoin instances which I call limits of dissection, as that in the cases above mentioned, though one action does not disturb or impede another action of a different kind, yet one action does overpower and extinguish another action of the same kind, as the light of the sun extinguishes that of a glowworm, the report of a cannon drowns the voice, a strong scent overpowers a more delicate one, an intense heat a milder one. A plate of iron interposed between a magnet and another piece of iron destroys the action of the magnet. But this subject also will find its proper place among the supports of induction. 44. So much for instances which aid the senses, instances which are chiefly useful for the informative part of our subject. For information commences with the senses. But the whole business terminates in works, and as the former is the beginning, so the latter is the end of the matter. I will proceed therefore with the instances which are preeminently useful for the operative part. They are of two kinds, and 7 in number, though I call them all by the general name of practical instances. In the operative part there are 2 defects and 2 corresponding prerogatives of instances. For operation either fails us or it overtasks us. The chief cause of failure in operation, especially after natures have been diligently investigated, is the ill determination and measurement of the forces and actions of bodies. Now the forces and actions of bodies are circumscribed and measured, either by distance of space, or by moments of time, or by concentration of quantity, or by predominance of virtue. And unless these 4 things have been well and carefully weighed, we shall have sciences fair perhaps in theory, but in practice inefficient. The 4 instances which are useful in this point of view I class under one head as mathematical instances and instances of measurement. Operation comes to overtask us, either through the admixture of useless matters, or through the multiplicity of instruments, or through the bulk of the material and of the bodies that may happen to be required for any particular work. Those instances therefore ought to be valued which either direct practice to the objects most useful to mankind, or which save instruments, or which spare material and provision. The 3 instances which serve us here I class together as propitious or benevolent instances. These 7 instances I will now discuss separately, and with them conclude that division of my subject which relates to the prerogative or rank of instances. 45. Among prerogative instances, I will put in the 21st place instances of the rod or rule, which I also call instances of range or of limitation. For the powers and motions of things act and take effect at distances not indefinite or accidental, but finite and fixed, so that to ascertain and observe these distances in the investigation of the several natures is of the greatest advantage to practice, not only to prevent its failure, but also to extend and increase its power. For we are sometimes enabled to extend the range of powers and, as it were, to diminish distances, as for instance by the use of telescopes. Most of these powers act and take effect only by manifest contact, as in the impact of 2 bodies, where the one does not move the other from its place unless they touch each other. Also medicines that are applied externally, as ointments or plasters, do not exert their virtue without touching the body. Finally, the objects of the taste and touch do not strike those senses unless they be contiguous to the organs. There are also powers which act at a distance, though a very small one, and of these only a few have been hitherto observed, albeit there are many more than men suspect, as, to take common examples, when amber or jet attracts straws. Bubbles dissolve bubbles on being brought together. certain purgative medicines draw humours downward, and the like. So, too, the magnetic power by which iron and a magnet, or two magnets, are made to meet, operates within a fixed but narrow sphere of action. But if there be any magnetic virtue flowing from the earth, a little below the surface, and acting on a steel needle in respect of its polarity, the action operates at a great distance. Again, if there be any magnetic power which operates by consent between the globe of the earth and heavy bodies, or between the globe of the moon and the waters of the sea, as seems highly probable in the semi-menstrual ebbs and flows, or between the starry sphere and the planets, whereby the latter are attracted to their apogees, all these must operate at very great distances. There are found also certain materials which catch fire a long way off, as we are told the naphtha of Babylon does. Heat also insinuates itself at great distances, as also does cold, insomuch that by the inhabitants of Canada the masses of ice that break loose and float about the northern ocean, and are borne through the Atlantic toward the coast, are perceived at a great distance by the cold they give out. Perfumes also, though in these there appears to be always a certain corporeal discharge, act at remarkable distances, as those find who sail along the coasts of Florida, or some parts of Spain, where there are whole woods of lemon and orange, and like odoriferous trees, or thickets of rosemary, marjoram, and the like. Lastly, the radiations of light and impressions of sound operate at vast distances. But whether the distances at which these powers act be great or small, it is certain that they are all finite and fixed in the nature of things, so that there is a certain limit never exceeded, and a limit which depends either on mass or quantity of matter in the bodies acted on, or on the strength or weakness of the powers acting, or on the helps or hindrances presented by the media in which they act. All which things should be observed and brought to computation. Moreover, the measurements of violent motions, as they are called, as of projectiles, guns, wheels, and the like, since these also have manifestly their fixed limits, should be observed and computed. There are found also certain motions and virtues of a contrary nature to those which operate by contact and not at a distance, namely, those which operate at a distance and not by contact, and again, those which operate more feebly at a lesser distance, and more powerfully at a greater. The act of sight, for instance, is not well performed to contact, but requires a medium and a distance. Yet I remember being assured by a person of veracity that he himself, under an operation for the cataract, when a small silver needle was inserted within the first coat of the eye, in order to remove the pellicule of the cataract and push it into a corner, saw most distinctly the needle passing over the very pupil. But though this may be true, it is manifest that large bodies are not well or distinctly seen, except at the vertex of a cone, the rays from the object converging at certain distances from it. Moreover, old people see objects better at a little distance than if quite close. In projectiles, too, it is certain that the impact is not so violent at too small a distance as it is a little further off. These, therefore, and like things, should be observed in the measurements of motions with regard to distances. There is also another kind of local measurement of motions which must not be omitted. This has to do with motions not progressive, but spherical, that is, with the expansion of bodies into a greater sphere, or their contraction into a less. For among our measurements of motion we must inquire what degree of compression or extension bodies, according to their nature, easily and freely endure, and at what point they begin to resist, till at last they will bear no more. Thus, when a blown bladder is compressed, it allows a certain compression of the air. But, if the compression be increased, the air does not endure it, and the bladder bursts. But the same thing I have tested more accurately by a subtle experiment. I took a small bell of metal, light and thin, such as is used for holding salt, and plunged it into a basin of water, so that it carried down with it the air contained in its cavity to the bottom of the basin, where I had previously placed a small globe, on which the bell was to light. I found then that if the globe was small enough in proportion to the cavity, the air contracted itself into less space, and was simply squeezed together, not squeezed out. But if it was too large for the air to yield freely, then the air, impatient of greater pressure, raised the bell on one side and rose to the surface in bubbles. Again, To test the extension as well as compression of which air was susceptible, I had recourse to the following device. I took a glass egg with a small hole at one end of it, and, having drawn out the air through the hole by violent suction, I immediately stopped up the hole with my finger and plunged the egg into water, and then took away my finger. The air, having been extended by the suction and dilated beyond its natural dimensions, and therefore struggling to contract itself again, so that if the egg had not been plunged into the water it would have drawn in air with a hissing sound, now drew in water in sufficient quantities to allow the air to recover its old sphere or dimension. Now it is certain that the rarer bodies, such as air, allow a considerable degree of contraction, as has been stated, but the tangible bodies, such as water, suffer compression with much greater difficulty and to a lesser extent. How far they do suffer it I have investigated in the following experiment. I had a hollow globe of lead made, capable of holding about 2 pints, and sufficiently thick to bear considerable force. Having made a hole in it, I filled it with water and then stopped up the hole with melted lead, so that the globe became quite solid. I then flattened 2 opposite sides of the globe with a heavy hammer, by which the water was necessarily contracted into less space, a sphere being the figure of largest capacity. And when the hammering had no more effect in making the water shrink, I made use of a mill or press, till the water, impatient of further pressure, exuded through the solid lead like a fine dew. I then computed the space lost by the compression, and concluded that this was the extent of compression which the water had suffered, but only when constrained by great violence. But the compression or extension endured by more solid, dry, or more compact bodies, such as wood, stones, and metals, is still less than this, and scarcely perceptible, for they free themselves either by breaking, or by moving forward, or by other efforts, as is apparent in the bending of wood or metal, in clocks moving by springs, in projectiles, hammerings, and numberless other motions. And all these things, with their measures, should in the investigation of nature be explored and set down, either in their certitude, or by estimate, or by comparison, as the case will admit. 46. Among prerogative instances, I will put in the 22nd place instances of the course, which I also call instances of the water, borrowing the term from the hourglass of the ancients, which contained water instead of sand. These measure nature by periods of time, as the instances of the rod by degrees of space. For all motion or natural action is performed in time, some more quickly, some more slowly, but all in periods determined and fixed in the nature of things. Even those actions which seem to be performed suddenly and, as we say, in the twinkling of an eye, are found to admit of degree in respect to duration. First, then, we see that the revolutions of heavenly bodies are accomplished in calculated times, as also the flux and reflux of the sea, the motion of heavy bodies to the earth, and of light bodies toward the heavens. It is accomplished in definite periods, varying with the bodies moved and the medium through which they move. The sailing of ships, the movements of animals, the transmission of missiles, are all performed likewise in times which admit, in the aggregate, of measurement. As for heat, we see boys in winter time bathe their hands in flame without being burned, and jugglers by nimble and equable movements turn vessels full of wine or water upside down, then up again without spilling the liquid, and many other things of a similar kind. The compressions also and expansions and eruptions of bodies are performed, some more quickly, and some more slowly, according to the nature of the body and motion, but in certain periods. Moreover, in the explosion of several guns at once, which are heard sometimes to the distance of 30 miles, the sound is caught by those who are near the spot where the discharge is made sooner than by those who are at a greater distance. Even in sight, whereof the action is most rapid, it appears that there are required certain moments of time for its accomplishment, as is shown by those things which by reason of the velocity of their motion cannot be seen, as when a ball is discharged from a musket, for the ball flies past in less time than the image conveyed to the sight requires to produce an impression. This fact, with others like it, has at times suggested to me a strange doubt, viz. Whether the face of a clear and starlit sky be seen at the instant at which it really exists, and not a little later, whether there be not, as regards our sight of heavenly bodies, a real time and an apparent time, just like the real place and apparent place which is taken account of by astronomers in the correction for parallaxes. So incredible did it appear to me that the images or rays of heavenly bodies could be conveyed at once to the sight through such an immense space, and do not rather take a perceptible time in travelling to us. But this suspicion as to any considerable interval between the real time and the apparent afterward vanished entirely when I came to think of the infinite loss and diminution of quantity which distance causes in appearance between the real body of the star and its seen image, and at the same time when I observed the great distance, 60 miles at least, at which bodies merely white are instantly seen here on earth, while there is no doubt that the light of heavenly bodies exceeds many times over in force of radiation, not merely the vivid colour of whiteness, but also the light of every flame that is known to us. Again, the immense velocity in the body itself, as discerned in its daily motion, which has so astonished certain grave men that they preferred believing that the earth moved, renders this motion of ejaculation of rays therefrom, although wonderful, as I have said, in speed, more easy of belief. But what had most weight of all with me was that if any perceptible interval of time were interposed between the reality and the sight, it would follow that the images would oftentimes be intercepted and confused by clouds rising in the meanwhile, and similar disturbances in the medium, and thus much for the simple measures of time. But not only must we seek the measure of motions and actions by themselves, but much more in comparison, for this is of excellent use and very general application. Now we find that the flash of a gun is seen sooner than its report is heard, although the ball must necessarily strike the air before the flame behind it can get out. And this is owing, it seems, to the motion of light being more rapid than that of sound. We find, too, that visible images are received by the sight faster than they are dismissed. Thus, the strings of a violin when struck by the finger are to appearance doubled or tripled, because a new image is received before the old one is gone, which is also the reason why rings being spun round look like globes, and a lighted torch carried hastily at night seems to have a tail. And it was upon this inequality of motions in point of velocity that Galileo built his theory of the flux and reflux of the sea, supposing that the earth revolved faster than the water could follow, and that the water therefore first gathered in a heap and then fell down, as we see it do in a basin of water moved quickly. But this he devised upon an assumption which cannot be allowed, viz. That the earth moves, and also without being well informed as to the sex horary motion of the tide. But an example of the thing I am treating of, to wit, the comparative measures of motions, and not only of the thing itself, but also of its eminent use, of which I spoke just now, is conspicuous in mining with gunpowder, where vast masses of earth, buildings and the like are upset and thrown into the air by a very small quantity of powder. The cause of which is doubtless this, that the motion of expansion in the impelling powder is quicker many times over than the motion of the resisting gravity, so that the first motion is over before the counter motion is begun, and thus at first the resistance amounts to nothing. Hence too it happens that in projectiles it is not the strong blow, but the sharp and quick that carries the body furthest. Nor would it be possible for the small quantity of animal spirit in animals, especially in such huge creatures as the whale or elephant, to bend and guide such a vast mass of body, were it not for the velocity of the spirit's motion, and the slowness of the bodily mass in exerting its resistance. This one thing indeed is a principal foundation of the experiments in natural magic, of which I shall speak presently, wherein a small mass of matter overcomes and regulates a far larger mass. I mean the contriving that of two motions, one by its superior velocity, get the start and take effect before the other has time to act. Lastly, this distinction of foremost and hindmost ought to be observed in every natural action. Thus, in an infusion of rhubarb, the purgative virtue is extracted first, the astringent afterward. And something of the kind I found on steeping violets in vinegar, where the sweet and delicate scent of the flower is extracted first, and then the more earthy part of the flower, which mars the scent. Therefore, If violets be steeped in vinegar for a whole day, the scent is extracted much more feebly. But if you keep them in for a quarter of an hour only, and then take them out, and, since the scented spirit in violets is small, put in fresh violets every quarter of an hour, as many as 6 times, the infusion is at last so enriched that although there have not been violets in the vinegar, however renewed, for more than an hour and a half altogether, there nevertheless remains in it a most grateful odour, as strong as the violet itself, for an entire year. It should be observed, however, that the odour does not gather its full strength till after a month from the time of infusion. In the distillation too of aromatic herbs, crushed in spirit of wine, it appears that there first rises an aqueous and useless phlegm, then a water containing more of the spirit of wine, and lastly a water containing more of the aroma. And of this kind there are to be found in distillations a great many facts worthy of notice, but let these suffice for examples. 47. Among prerogative instances, I will put in the 23rd place instances of quantity, which, borrowing a term from medicine, I also call doses of nature. These are they which measure virtues according to the quantity of the bodies in which they subsist, and show how far the mode of the virtue depends upon the quantity of the body. And first there are certain virtues which subsist only in a cosmical quantity, that is, such a quantity as has consent with the configuration and fabric of the universe. The earth, for instance, stands fast, its parts fall. The waters in seas ebb and flow, but not in rivers, except through the sea coming up. Secondly, almost all particular virtues act according to the greater or less quantity of the body. Large quantities of water corrupt slowly, small ones quickly. Wine and beer ripen and become fit to drink much more quickly in bottles than in casks. If an herb be steeped in a large quantity of liquid, infusion takes place rather than impregnation; if in a small, impregnation rather than infusion. Thus in its effect on the human body, a bath is one thing, a slight sprinkling another. Light dews, again, never fall in the air, but are dispersed and incorporated with it. And in breathing on precious stones, you may see the slight moisture instantly dissolve, like a cloud scattered by the wind. Once more, a piece of a magnet does not draw so much iron as the whole magnet. On the other hand, there are virtues in which smallness of quantity has more effect, as in piercing. A sharp point pierces more quickly than a blunt one. A pointed diamond cuts glass, and the like. But we must not stay here among indefinites, but proceed to inquire what proportion the quantity of a body bears to the mode of its virtue. For it would be natural to believe that the one was equal to the other, so that if a bullet of an ounce weight falls to the ground in a given time, a bullet of 2 ounces ought to fall twice as quickly, which is not the fact. Nor do the same proportions hold in all kinds of virtues, but widely different. These measures, therefore, must be sought from experiment, and not from likelihood or conjecture. Lastly, in all investigation of nature, the quantity of body, the dose, as it were, required to produce any effect must be set down, and cautions as to the too little and too much be interspersed. End of Aphorisms 41 to 47 of Book 2. Recording by Jeffrey Edwards.